Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we continue talking about graphics and images, and we're going to apply some of the things we learned about images last time to look at a technique called double buffering, and also demonstrate to you the texture paint. So, last time we wrote a little program that used an image here. We created a buffered image, and we showed how you can call create graphics on it to get a graphics 2D object that then you can do things with the same way we've been doing things with the graphics 2D that was passed into the paint method. And we also saw how you can use set RGB to poke basically pixels directly into the image. And there's also a get RGB that allows you to read those out. There are some projects in the book where it's helpful to be able to do those things. And when we ran this, it pops up a little window, and it gives us a GUI that has basically a blue image that has some red and green superimposed on it. And then we also used image.io to read in these two images and display them. Now, what I'd like to do, and in order to motivate the idea of double buffering, I actually need to make something that takes a while to draw. So right now down in our paint, we are drawing basically directly to the screen. And that's fine if you only need to draw a few things. So if I sit here and I resize this, actually the way that this is set up, it doesn't refresh it. I'll have to put in something so that we can force refreshes inside of here. But everything works fine if I'm drawing a small number of things. What I'd actually like to do is I would like to put in the ability to have to draw a large number of something. And since I don't really care that much about what it is, I'm going to go with a large number of random small points. So if we create a new I'm going to make an array called points, and I'm going to put 10,000 points in here, each of which will be a tuple of math.random times 200, math.random times 200. That will be for an x and a y value. And then if I come down here, and what I want to do is simply go through this x comma y in points g dot fill new ellipse 2D dot double. It'll basically be literally just a little point here. And now if I run this, now since there are 10,000 of those, I'm not yet importing my import java.awt.geom._. Save, run. Okay, so there I have 10,000 points. Who knows, I might actually have to take the number up a little bit. And what I would like to do is to make it so that this has to redraw regularly, so that you can tell the difference between it just being a static image and something else. And probably the best way to do that might be to actually give us a border panel. And have a button. We'll talk about other ways of doing this in a bit. Layout plus equals panel for border panel. Actually, we're inside of a border panel, so will it work for me to just do position dot center, layout plus equals button, repaint, and I want this to call panel dot repaint. Let's see if that's happy. Nope. I have to put in border panel. We're inside. It's inside the border panel object, and I am working inside of a border panel class. So. Oh, and I need to also put in something that clears the whole background. So g dot set paint. This is one of these interesting things where, as a teacher, as computers keep getting faster and faster and faster, it can actually become problematic, because some of the examples of stuff that you want to show, you're battling against the computer being too fast. So I want to show how this can lead to flickering, but as the computers get faster and faster, it can get harder and harder to make things flicker. There are lots of other places where this winds up being motivated. I have a G instead of an S. Okay. In particular, when you start doing classes about data structures. Apparently 10,000 is not enough for me to get flicker on this machine, and of course there's no guarantee. Let's just go up 2 orders of magnitude, so we'll go to 1,000,000, and I will pull these from the full range of 500 by 500, hopefully drawing 1,000,000 little circles. Yeah. That might be too many. Let's close it and take it back down to 100,000. Where this really matters is when we start talking about animation in a little bit. What happens if I do some dragging? No, I'm not going to be able to get flicker for you the way that I'd like to here, but I can still show you the concept of double buffering and why it would be important. This is a lot of drawing here to this graphics object G, and the way that it's actually happening, it's drawing directly onto the screen. And so if I had this refreshing quickly enough, which I would want to do for animations and such, and we'll see this later, you could actually have it where the user sees the whole screen go white for a second and then sees other things popping up, and so you get a flickering effect on there. And it's very annoying, and you've probably seen applications that have this type of flickering effect, and basically it sucks, and so we want to avoid it. Well, one way to avoid this is, instead of drawing all of these things to the graphics object G, we draw all of these things to a background image. And then at the very end, we throw that image up onto the screen. So I'm going to make a new buffered image. I'll call it B image for the background image. And I am going to make it so that it is 500 by 500, and image.type int argb. And I like that because it let's go ahead now, do that in here. Val gr equals bimage dot create graphics. And what I'm going to do is just change all of these G's to GRs. So this means that I'm not drawing to the screen here, I'm drawing onto this image, and then the last thing that I do is I do G dot draw image of B image 00 null. let's try running this real fast. Okay, and had I been able to click to create Flickr before, you wouldn't get it now, because what's happening is it takes this and it goes through all the steps of draw this, draw this, draw this, and then draw 100,000 little dots, but do it off to the side where the user can't see it, and then right at the end throw it up on the screen, so that the act of drawing is kind of hidden from the user and it prevents the image from flickering. Now, one potential problem with this is the fact that my image only extends to here. That's fine in this example. Had I wanted it to extend further, I might do something like this. And this is the reason why I made my B image a var. If size dot width is greater than B image dot get width, or size dot height is greater than B image dot get height, that means I need to make a new image, and I need to make it so it's big enough to hold everything that I want, my entire panel. So I will just make a new image there. And once again, this doesn't greatly affect this application because what was being drawn doesn't change as I make this larger or smaller. But if I had made it so that the positions of various things scaled with the width and height of this panel, I would need to be able to do that. So I could make a bigger image, because otherwise the things that didn't fall in the image would be truncated off. The other thing that we can use our images for is inside of the texture paint. So when we talked previously about the paint settings, so inside of java.awt we had our graphics 2D type, which is where we're drawing everything to, and we looked at the fact that we can call set paint, and we pass it a paint type. And one of the different paint types that we had that we could use was a texture paint. We didn't look at this one earlier, and the reason is because it takes a buffered image, so you had to know what buffered images were. So texture paint takes two arguments, a buffered image and a rectangle 2D, which is the anchor. And you can read in here that the rectangle 2D is the space basically on the screen where this image should appear. So one thing, so if I wanted to, on top of all these random dots, I am going to, and I'll do this actually, we can do it to gr dot fill a new rectangle 2D dot double let's go ahead and let's pull this back to like 100, 400 and make this 300. If I do this right now, I'll just get a black rectangle. So let's make sure we're happy with, I'm missing a close parentheses, okay. Make sure we're happy with where this comes out. Okay, that'll work for me. And what I want to do though is I want to set the paint here to use a new texture paint, and the texture that I want to paint with is one of the images from above. I'm going to use the art image, and then let's verify that it's a rectangle 2D. I am going to make it, actually I'll have it start at 0, 0, comma, let's go with a height of 100 and a width of 50. one more close. And we need to import this. Notice that what happened here was I get my textbook, the cover here, and this is actually the paint now that's being used, and it tiles it across the background. It happens to line up perfectly because of the sizes that I gave it, because it's set over 100 and I told it to use a width here of 150. So every version of this image is 100 pixels across and 50 down, which is why two of them stack nicely there. If I had used a slightly different size, something that was not a nice multiple, so let's just say we make this 85 and this 93, close this and rerun it. Now you can see that they're kind of off. And if I had wanted it to start in the top corner of the rectangle, I could have, instead of having it start at 0, 0, I could have it start at the location that my rectangle starts at, which is 100, 400, and then we get this. And since I made them a little bit too short and not quite, so you have partial images that hang off the edges, but that shows you how you can take basically anything that you would call draw or fill with. So you could do this with any of the examples where you had things like you have a stroke that has a dotted line. Well, you can make it so the dotted line is filled with any image that you can find. And those types of things, those are all possibilities by using a texture paint. So that's it for this video, and we'll come back next time and we'll show you how to make this interactive.